All right, so let's go over some things on the midterm. So overall, it looked like people mostly were in good shape on this. A few places where people got nickel and dime, but by and large the grades tended to fall out into the high end or sort of the lower end with not too much in the middle. So let me talk through the questions, but also point out some specifics, not all of which cost points. So question 1, you were creating a vector class with 4 pieces to it. So a constructor that lets you pass in 3 arguments and create a vector with those components. A method named length that returns square root of the sum of the squares, length of the vector. A method named normalize that adjusts the x, y, z values to give you a vector of length 1. And then a 2-string method so that if you try to print this, you get x, y, z in parentheses with commas in between. And not too many issues with this, despite all the red. Mostly little things. So one, I forgot to get paper. I gotta run out of paper really fast. One thing that I saw in some cases was something like this. So class vector. Double x, double y, double z. Set up the fields in the class itself, and so this is not a class, this is your constructor. But inside the constructor, I saw this. Length equals math square root x times x plus y times y plus z times z. Find the length. And other stuff. And then in the normalize routine, x, y, and z get divided by that length. And I've seen this before, and there's one issue with this, which is that you can compute the length of the original vector in the constructor. That's the length of the vector that you just constructed. But when you're down here in the normalized routine, how do you know that len is still the length of the current vector? What if x, y, and z have changed since it was constructed? Right? And I've seen this happen in other cases. It's a common issue where you give a variable a value at one point, but that value isn't necessarily meaningful at a different point. So a different way to do this you have a length routine, right? So in part B, you're defining a method called length. So you could do something like double len equals length, and then x equals x over len, y equals y over len, z equals z over len, and not do this at all. So at the moment where you're ready to normalize this vector, you find what its current length is, and you could also just say len equals math.square root x squared plus y squared plus z squared. But since you've got a length method that you just wrote in the previous question, right, you can take advantage of that and just call it here, and then just take x, y, z and divide by that length. So here's a mistake that didn't cost you any points. But I want you to think about it. So what's wrong with these statements? Because it kind of looks like it's doing the same thing as this.
length is gonna change each time you,
Yeah, so as soon as you adjust x, when you call length again, you're getting a different length from what you had the first time. And so you're doing some kind of strange normalization here. So if you do this, find the length before you make any changes to x, y, z, and then divide. I didn't take off for that because that's a really easy mistake to make. And it can be a little subtle to find, but if you do this, your vectors will get wonky. That's a technical term. And when you go in, you try to figure out why is y and z taking on these weird values, right? You'll go in the debugger, you'll start tracing through, and you'll see at this point y took on some strange value, and eventually you'll figure it out. And then you probably won't do this again too many times. But it can be really subtle. So I saw that sometimes. All right. So question 2 was just playing around with this particular class called main. So what's the class name? That's main. I think everybody got that. How many constructors are there? So anything that has the name of the class as the method name, it's not really a method, it's a constructor. So there's one constructor, there's another constructor. Different signatures because the argument lists are different. So 2 constructors. How many methods, not counting constructors, are there? There's only one create. Right, so that's a class instance method. What's the effect of main m equals new main parentheses 8 comma minus 2? Well, it's going to call the constructor that expects 2 integers. That's this constructor right here. So what does it do? It creates an instance of main. It sets m equal to that instance, and in that object it sets x equal to 1. And that's really all that happens. There's a lot of things that don't happen. Like it doesn't do anything with x2 and y2, and it doesn't do anything with a and b and y, right? But the main effect is creates an instance of main called m, and it sets m dot x equal to 1. And then we wanted one line of Java code to create an object of type main and set the value of a to be 24, and you're only allowed one line of code. Well, there's 2 constructors. If we use this first constructor, that sets the value of x, it doesn't touch the value of a. Okay, so if we use the one argument constructor, that does set the value of a and sets to whatever the argument is. So doing something like main m equals new main 24 will create an instance of main with a equal to 24. So that would suffice for part E. And then part F, you want 2 statements of Java code to create an object of type main, and you want 2 things to happen. You want x to be equal to 1, and you want a to be equal to 24. And you're only allowed 2 Java statements. So again, look at your constructors. We can set a equal to the argument, or we can set x equal to 1. So we can take care of either one of these in the constructor, and then we have to use a statement of Java code to take care of the other value. Well, the only other thing we have is one method called create, and create adjusts the value of a. There's no way to change the value of x once you've created it. So let's create it with a value of 1, and then let's call create, construct it with a value of 1, and then call create to set the value of a. So we can do something like main m equals new main. And we're doing the one argument constructor, so it doesn't matter. Sorry, we're doing a 2 argument constructor. It's going to set x equal to 1. Doesn't matter what the arguments are. It doesn't use x2 or y2. So we could just use 0, 0 as anything else. So that sets x equal to 1. And then to set a equal to 24, we can use the create method. So we can say m dot create and give it any 2 arguments that add up to 24. So 12, 12, or 24, 0, or 1,024, negative 1,000,000, or whatever. So those 2 statements would do it. You didn't get credit if you gave me 2 constructors for 2 different objects, where one object had this and the other object had this. So that's just playing around with the code and seeing what it does and then working with it. All right, scanner class, read words from standard in, separated by white space, count the words that begin with an uppercase A or lowercase z, and at end of file, print out the count. So the main thing you're working with in here is scanner. Right, so set up a scanner on system.in. Won't throw an exception, so you don't need to try catch it. And then sc.hasNext tells you if there's a token, right, a word separated by white space ready to be input, so you can say while sc.hasNext. And you can actually read that word by saying sc.next. All right, so the biggest issue people had here was picking off the first character. Okay, probably the easiest way to get the first character of a string is to say word dot character at index from 0, so that'll be the first character. Okay, and that was one of those methods I said you should know about strings, character at. You can use a substring method to create a 1 character long string, and then use the equals method on that to see if it's equal to double quote A. But characters are easier to work with than strings. Okay, character is just a single character. Strings are collections of them. So you could work with this directly. You could say if this thing is equal to an A or this thing's equal to a Z. Or you could save this in a character. So character C equals. And then if C equals A or C equals Z. So things that you want to know here. Characters come in single quotes. Strings come in double quotes. Right? These are different types of creatures. Okay, even if it's a single character, if it's in double quotes, it's a string. Totally different class. Characters, we can use double equal to compare. We can use exclamation equal to see if they're different, and so on. Strings, we can't use double equal. Okay, it's not a primitive type, so we need to use dot equals, for example. Characters, we can just say C double equal this. This is how you do ORs between logical expressions. The result of this is a Boolean, it's true or false. The result of this is a Boolean, true or false. A true or false or a true or false does the logical OR. Okay, so it's 2 pipes, 2 ampersands does a logical AND. So the result of this whole expression is true precisely when the first character was an A or the first character was a C, a Z. So you want something like a running count. And if either of those is true, go ahead and increment count. And I still throw things in curly brackets even if there's only one statement. But that's up to you. And that's pretty much the end of your loop. So it will continue to loop. And remember, when hasNext is called, you go inside that hasNext method and you block. Your program sits inside that method until either a bunch of text comes in followed by white space or end of file is detected. If it's stuff followed by white space, this will come back and return true. If it's end of file, it'll come back and return false. So your hasNext is going to return when you are ready to move on. And if you hit end of file, it'll be false, you'll kick out of the loop. Otherwise, it'll go on to the next statement, and your call to sc.next will return whatever that string was that got you out of has next. So these are almost always done in pairs, whether it's next has next, or next line has next line, or next int has next int, or whatever. And at the end of this, what do we want to do? We want to print, so system out print line. And if you want to print count, count as an integer, you can just say count. Okay, I think I saw one case where somebody did new integer count to construct an integer whose value is equal to count, and then called the toString method and pass that to print line. That works, but it is very, very needless, right? A primitive integer print line will print directly. And if this was an actual integer uppercase I and I tried to print it, it would go ahead and call the toString method, right? And it will do the right thing. This is explicitly spelling out what it was going to do for you anyway. So if you could offend the JVM, that would probably offend it, but you can't as far as I know. Be careful about using this next method. In 224 and somewhat in 222, I emphasized using fgets and scanf, right? Remember that? So I said use fgets to read a line of text and then scanf to parse it. And my reason for doing that was to split up the input and the parsing operations. Think of this as an input operation. And by saving this in a variable, we can do things to that variable 1,000,000 times, right? And it's got nothing to do with inputting from standard in. Here's where the input happens. Everything else is where we process it. So here's something that I saw in some cases. So this returns a word. This returns a character. And I saw an if statement like that. So what's possibly going to go wrong with this?
It's going to read in 2 words.
It's going to read in 2 words. It's going to read the first word, and if it doesn't begin with an uppercase A, it's going to read in the second word and see if that begins with a lowercase z. And that's really not what you want it to do. But if you look at this and you think, well, I'm reading a word and seeing if it's an A or a Z, right? This looks perfectly fine. It's going to be really frustrating to try to debug unless you actually go into the debugger and step through it. So that's another really easy thing to do, but it doesn't do what you want. So we'll just say no. Using has next and next is not the same as using has next line and then splitting on spaces. Okay, next will split on spaces, tabs, new lines, vertical form feeds, all kinds of white space. Split will only split on a space if that's what you ask it to do. So it doesn't give you the same thing. This is a good one to know if you're trying to split on things separated by spaces, white space. Anything else on here? I think that was pretty much it. Let's look at question 4. So question 4 is using try-catch blocks, right? So this is a divide method. You pass it an x and a y. It divides them and returns the quotient. And if y happens to be 0, you can get an exception. So I wanted you to use try-catch blocks to catch that case and print your own error message and return 0. So it's not just checking to see if y is equal to 0, and if it is, do something different. I wanted the mechanisms of try-catch. So how do you do that? Basically, before you do the thing that might cause an exception, say try, curly bracket, and then do the thing that might cause the exception, and we can go ahead and return the answer if it succeeds, and then close your curly bracket. And then catch, and you have to tell it what kind of exception to catch. And we can use the word exception, that's the most general class that will catch any exception. And you have to put a name of a variable, an object that will take on the value of that exception. So catch parentheses exception E, curly bracket, and then put in what you wanted to do if this divide through an exception, which in our case is print an error message and return 0. So system out, print line, whatever, and then return 0. So if y is not 0, the try block will do this division successfully, it'll return, and you're done. If y is 0, this throws an exception, you jump down here. We don't use this variable e, but it's got to be present. It's part of the syntax of the catch statement. So in here, we just print our message, return a 0, and you're done. All right, question 5 probably gave people the most problems. This was the linked list question. So our class is named list. Do we have a sentinel node here or not? How do we know we don't? What? Doesn't say sentinel, but I might not use that word. I might call it a header. Yeah.
Because when it's being constructed, it's being set right at the, I mean, it's being set to null, but every method in here starts at the first node.
Yeah, every method starts at the first node. When it's constructed, it's set to null. What about this? There's a comment. It says header is the first node, or it's null if the list is empty. Right? So I put that in there deliberately to tip you off that there was no sentinel involved here. So yeah, however you get there, there's no sentinel, okay? And I gave you the add method here, but you don't actually need to do anything with this. This is just here in case you want to make sure you understand what's going on. But this is just a generic add method for putting something in the beginning. And this is what the nodes of the list look like. There's a data piece, which is a string. There's a next pointer, which is another node. So it's the list that you should be familiar with from Pt1, right? So what did you want to do in here? You wanted to traverse the list, compare each node's data to a given word, count the number of nodes that differ from that, and then return that as the function's value. Well, we got to traverse the list. You need to have some kind of variable that you can use as a pointer to each node that you're looking at. Okay. And we know that header is pointing to the first node of the list. Can we use header as our temporary pointer? Why not? Yeah, we can use it exactly once, and then we've destroyed access to our list. So usually the header is pristine. The root of a tree is pristine, right? It's a variable within this class. Now if we declare a variable inside a method and we set that equal to header, we can change that. It's a temporary variable. It's local to that method. But this is in some sense global. It's the header. It's the handle to the list. So we don't really want to change that. So we could do something like node, let's just call it pointer, and set that equal to header. And now we want to traverse our list. Okay, so this is one of these things where there's several ways to deal with a linked list. We can start off with the header node and say, well, the header's not null. We can check the header node manually and then say, well, header.next is not null, and make sure we don't throw an exception. We can say pointer equals pointer.next in the beginning or the end of the loop. We can check pointer.data. We can check pointer.next.data. There's all these different variations, okay? and I saw all of them. And it's not that any of them are inherently wrong, okay? It's actually, I think, really, really useful to think about all these different varieties of how to go through a linked list, how to search for something, for example. Because you want to be fluent with these concepts. And the more you kind of force yourself to think about them differently, right? I always do my linked list code like this. Well, what if I didn't? What if I had to start off by looking at the thing that the header points to, right? So I'd need a separate set of code in the beginning to see if that first node was what I was looking for. And what would my termination condition look like? The more you kind of force yourself through those exercises, the more fluent you're going to be with this. And this is sort of fundamental data structures, right? If you can understand and work and adapt to different versions of code and algorithms for a linked list, it's really not that different for trees or other kinds of data structures. The detailed mechanics vary, but the concept of using nodes and worrying about exceptions and things like that, they're kind of the same thing over and over. So it's fair game to play with it. But let's and sometimes it's a trial and error thing. But here's how I kind of trial and error this. I know that pointer right now is a data node, and I need to consider its data. That's one of the values I need to think about. So somewhere down here, I'm going to see if pointer data matches word. And I also know that I do not want to look at pointer.data if pointer is null, because that'll give me an exception. And I know I need some kind of loop. And so my first shot might just be while pointer is not equal to null. Now, is that right or not? I don't know yet. Okay? And when I was learning this stuff, I couldn't tell you right away, is that the right thing to do or not? Take a shot, put it down, and then work through it, right? That's really good exercise. Because when you're debugging or you're writing code, or you're looking at someone else's code, or you're doing a test or anything like that, right? What you want to do is be able to look at code and figure out in your head what it's doing, right? Really, really good practice. So I'm just going to start off with while pointer's not null, because I know that'll keep me safe over here, right? So if pointer's not null, I'm going to check pointer.data. Well, that's going to start with the first node, so that's good. And then somewhere at the bottom, I'm going to adjust pointer to be the next node. And I can think about that, and if pointer is the last node, then this is going to change pointer to be null. And when I come up here to my while loop, it's going to say, well, pointer's not null, it's going to kick me out of my loop. And the last thing that I looked at, PTR, was the last node. So I know I'll have considered the last node's data as well as the first. So that feels pretty good. And in fact, this will work correctly. Okay, so that's one aspect, is just the mechanics of going through the list. And then there's this question of how do we tell if the pointer's data matches the word? And this caused some issues. So pointer.data is a string. Strings come with equals methods. And we can give that equals method another string. And this will tell us if pointer.data contains the same string as what word contains. And it says we want to count the number of times, the number of nodes where the data value is not equal to the given word. So we want to increment if this is not true. So we can put an exclamation mark that negates a condition. And if this is the case, let's increment count. Well, what is count? It's our global counter, so I'm going to initialize it as an integer equal to 0 before I get into this while loop. And at the end, We just want to return count. Alright, so you can't use equals equal, you can't use exclamation mark equal, you can't use exclamation mark equal equal. Okay, equal equal on strings compares the object's identity, not the actual value of the string. If you had things that in here that might throw an exception because you were checking a data field before you checked to see if it was null, or if you were missing the first node or missing the last node or counting a node twice or something, I tried to put a comment in there to indicate that. But if you're not sure what I meant, go ahead and ask me. So here's something I saw that I don't think you should ever write. And in 224 I say, you know, whatever makes sense to you is the right way to do it. I didn't really say that as much in 222, and I'm going to say that even less in here. Okay, so here's an example of something that logically makes sense, but don't write this. So something like this. It makes sense, right? If the words are equal, don't do anything. Otherwise, increment the count. Okay, but what you really want to do is say, if the words are not equal, increment the count, right? And all you got to do is throw an exclamation mark in the front of your condition. Okay, and this is something that'll raise eyebrows. Okay, saying, I don't think this person knows how to negate a logical condition. Right. So if you're not familiar with that or comfortable with it, right, play around with it and be friends with the exclamation mark, because it really makes your code simpler and arguably more efficient, perhaps. So that one I took a point off for, just to make sure you notice it. All right, question 6 was looking at static methods and instance methods. So our old rectangle class from week 1. So rectangle, double height and width. Constructor with no arguments sets height and width to 1. Constructor with 2 arguments sets height and width to those values. And area returns the integer area. For some reason it's an integer. That might be a typo. So part A, I wanted you to make a method called diagonal that returns the diagonal of the rectangle. Okay, and it's an instance method. So remember what instance methods are about. If you say something like rectangle R equals new rectangle, and you pass it no arguments, or you pass it 2 arguments, but you construct a rectangle, right? Whatever that rectangle is, we can say r dot diagonal without arguments, and it'll tell us the length of the diagonal. To do that, to find the length of the diagonal, it has to know what the height and width of the rectangle are. Where does it find those? It finds them from R, because R is an actual rectangle. It's an instance of a rect. So R has a height and it has a width, and this diagonal method will use R dot height and R dot width. But in part B, when you write a static method named perimeter, we're looking for a method that exists independent of any particular instance of a rectangle. So in this static method, height by itself has no meaning. Right? Height only has a value when we've constructed a rectangle. If we're not constructing a rectangle, there's no such thing as what's the height of this rectangle. There's no rectangle at all. So a static method, typically you're going to pass arguments to for something like this. So here we want a method that you pass a pair of arguments, the height and the width, and it returns the corresponding perimeter. So you could do something like double perimeter, and you pass it a pair of arguments, double H, double W. And it returns 2 times H plus W. All right, and then part 3 was looking for a 1 or 2 line example to use that method from part B to print the perimeter of an 11 by 13 rectangle. So we can invoke a static method by using the name of the class, in this case rect, followed by the method name. And we wrote the perimeter method to accept a height and a width, so we can call it with 11 and 13. And this will return a double, right, if that's how you declared the perimeter method. And so if you want to print this, you can just put it inside a print. And print line, if you give it a double, it will print it. Okay, you don't have to convert it to anything. But I saw some cases where people took the return from rect.perimeter and then called its toString method. And doubles do have a toString method. Or where they called big double dot parse double or convert and tried to manually convert this thing into a string, or it took this and did a plus quote quote to force concatenation, but you don't have to do any of that, okay? Print line will accept integers, doubles, floats, booleans, strings, right? All of these basic types will print correctly, characters. If you give it something that's not a primitive type, like a double lowercase d, and it's not a string, it will call that object's toString method to turn it into a string. But for something that's bringing back a double, you can just put it straight in as the argument to print line. And if that's confusing to you, right, spend 5 minutes playing around with print line. Just write a program that just calls system out print line and pass it different types of things and see what it does. Pass it a double lowercase d, a double uppercase d, a rectangle, an integer, big I, little I, and so on and so forth. All right, so question 7, kind of like the vector class, so making a class named myClass, contains 3 integers x, y, z, pair of constructors, one where you pass it the values for x, y, z, another where you pass it a single integer that's assigned to all of x, y, and z. Method named sum that returns the sum of those, and init which sets x, y, z to 1. Not too much trouble with any of those. The last one was a method named equal that tells you whether x, y, and z are all equal to each other. And that one, there was really only one kind of mishap I saw, which was this. And that does not do what you would hope it would do. Okay. One of these will evaluate to a Boolean, and it'll compare a Boolean to an integer, and we'll get all kinds of unhappy. We know what this means, right? But this is not something that a lot of languages understand, and unfortunately the ones that do understand it usually don't understand it the way you and I do. They get into all kinds of weird things. So that's another no. This will work. If x equals y and y equals z, so 2 ampersands, combine 2 Booleans with conjunctions. So if this is true and this is true, and some people did this, is that necessary though? Right, there's a transitive property for equality. So if x equals y and y equals z, then we know that x is equal to z. But if that feels more complete, I'm okay with that. But not strictly necessary. Gotta have 2 equal signs, not 1. Okay, 1 equal, Java will actually throw an error, C doesn't. The other thing I saw, not just here, but in a lot of other places, was people going a little crazy with this. Right, so let's look at your sum method. So sum, these are integers. That works, but you don't need to be saying this because the only x I could be referring to is the x that's part of the class, right? Unless I have a local variable x declared in here, x by itself means the same thing as this dot x, right? So I would avoid doing that unless you think somehow it's going to make it really clear. And if it does, then it's probably because I picked really bad variable names like x, y, z that are extremely generic, right? So if you've got something that's a variable of the whole class, give it a reasonable name, right? And then anytime you see that name, you should know that that's a class variable. And really the only time where we need to do something like this is when this name was so well chosen that we actually want to use that same name in the constructor or somewhere else where we're trying to do something. And now in one piece of code, we have a local version of this as well as the sort of global version, and we need to differentiate, so we use this. But if there's no other x or y or z in sight, you don't have to keep saying this dot x, this dot y. Okay, so if I went crazy crossing out your this is, that's what I was talking about. But I didn't take off for that either. 1 and 0 are not the same as true and false. Okay, in C they are, in Java they're not. In Java, equals method returns a Boolean. Okay, true and false are Booleans, and they can't be replaced with 1 and 0.
So only in C is 1 is true and 0 is
Yeah, in C actually 0 is false, non-zero is true.
But not Java.
But not Java. Java true and false are actually separate things, they're Booleans.
Okay.
All right, and this one I think we talked about at the end of class on Wednesday. Was that after the break on Wednesday?
No, that was the A and Z one.
Oh, okay. So, okay, I talked with one person after class on this. So, example of a class method. So, a static method, right? So, definitely math.square-root is a static declaration, static method. But also so is main, right? Because it's declared static. So that's another class method. This would be an example of using a class method, but they're both good instances of class methods, or examples of class methods. An instance method would be something like s.length, right? And you can tell because s is an object, it's a string, and we're invoking the length method of that instance. Object construction, look for the keyword new, right? So we're saying s equals new string, that's constructing an object of type string. So that would be an example of object construction.
You construct a new string by passing it a string.
You can. Or you can just say, you know, s equals quote blah.
Yeah, that's why it's.
Yeah. There's lots of ways to construct strings. All right, so come and talk to me if you have questions about that, or ask them in class. Catch me in my office hours, or ask during class. All right, let me